So in this video, we're going to be starting to look at projectile motion, and I'm going to give you a very basic and brief idea on what projectile motion is actually, what projectile motion is actually what? Projectile motion. Now, the motion that we are actually used to in general physics is going to be linear motion. So let's say we have a car. This car is moving forward. This car can also move backwards. A car will never fly, so we're only moving in one direction. So if this is the ground, I know my drawing is not that great, but the car is moving either horizontally or it's moving vertically, meaning it's moving in the x-axis. Now let's say a ball. You may throw a ball upwards, or maybe from top of a building, you may throw a ball downwards. So this ball can either go up or it can go down, meaning you're moving it in the y-axis. However, in real life, let's say you take the same ball and you throw it somewhat at an angle. All right. So let's say this is your starting point. Let's say you're throwing it from your chest level or from a starting point of the ball, from an angle to that starting point. All right. So it's thrown at an angle over here. And you will notice that the ball will actually move in this sort of a parabolic trajectory. You can do the same experiment with anything you have at your home, like with a pen or even with a ball. You can just throw it and you're going to see a ball will kind of move in this parabolic motion. This specific motion, this motion is known as projectile motion. So let's go and dive a dip into what projectile motion actually is. And we also need to consider a few points when we're actually doing or trying to study about projectile motion. Next, we are ignoring air resistance. Ignoring air resistance. So when we carry out projectile motions on Earth, and if we throw up something at an angle, or let's say we are throwing down something at an angle, and the object is falling, the object is going up, these sort of motions, let's say the ball is here. When the ball is here, it may be moving on this diagonal, but there will be air resistance that's acting on the object. We will ignore that air resistance for calculation. Now, the reason we're ignoring air resistance is going to be explained a bit later as I move on to more further calculations regarding projectile motion. So these are the basic knowledge you need to know before working with projectiles or working with maths related to projectile motion. And the final point that we're actually going to have to study to understand is the horizontal and vertical motion are independent of each other. So the projectile moving horizontally and the projectile moving vertically, both of these are independent of each other. And we are going to look at this in theoretical perspective soon. All right, so let's start with the most common projectile motion that we will come across in our life. So let's say this is the ground. And you have a small cannon. And you throw a cannon somewhat of like this. This is the projectile motion. And we're going to consider this angle to the horizontal as alpha. Now, to make the math simpler, we're going to make the model a bit more simple. So we're going to remove the cannon just for a sec. Right here. We're going to remove this line and the cannon. And we're going to consider the motion of the ball starting from the ground. And this angle, we're going to call it alpha. So a cannon is thrown vertically upwards. And it goes in this parabolic trajectory and goes and falls up to a certain point. So let's go and get familiarized with a bit of new terms. This cannon itself is known as the projectile that we are projecting. How far the cannon has moved is known as the range of the cannon after it's been projected. And this angle right here is called the angle to the horizontal. Meaning It's the angle from the equilibrium position of the projectile, horizontal. So if you want to find out specific terms and specific values from this projectile, we got to go ahead and understand a few concepts. So let's go ahead and get started with, let's just say I want to find out the maximum height of the projectile. So since the ball is moving somewhat like this, it can move somewhat like this, it can move like this, or they're going to a certain point, they reach a maximum height. So before I do that, I want to go ahead and clarify some things. First of all, we should always make a practice of dividing the components of the projectile. And let's go and try to understand why I had said that this point, horizontal and vertically, they are independent. This is the vertical, this is the horizontal, and both of them are independent. So let's say this ball is thrown from its equilibrium point, which is your hand. Let's say you're throwing this ball from your hand. You're throwing this. I know my hand's pretty bad, but you're throwing this at an angle. Now, once the ball leaves your hand, there is no backwards force it's pushing. It has already gained enough chemical potential energy from your hand so it can actually move in this parabolic trajectory. So that's the reason you may have horizontal component, but you will always have vertical component. So this means that this horizontal and this vertical component, so this vertical component and this horizontal component are independent of each other because they're influenced by different things. The vertical component is basically due to gravity. And the horizontal component is due to the initial force due to your hand. So force due to hand, or whatever the projectile is being projected with. So let's go and try to understand a few maths from this part. So as I told you, the horizontal and vertical components of a projectile is different. So we're going to go ahead and divide this to the horizontal component and to the vertical component. So this is going to be the y component, or vertical. This is going to be the x component, which is going to be the horizontal. So if I want to find the height right here, we have to consider a few things. How can we come into the height over here? Now, do remember that projectile motions do actually work on Newton's mechanics, or general mechanical rules on Earth. So you can use the Suvat equations. We can make use of Suvat equations when working with projectiles. Okay. So if you want to find out the height, or the maximum height the ball reaches, let's go ahead and break down the ball's motion. So the ball is initially over here with two of these vertical and horizontal components, and the ball is moving at this steady pace. Now, I'm assuming that you guys already know on how to derive and how to understand, like you already have a basic idea on what vertical and horizontal components of a vector is. So I'm not going to go in depth and explain them, but if you do need explanation, then the comments are always open. So notice that the ball is moving like this. So it's moving in this parabolic trajectory. This is how the ball is moving in the parabolic trajectory. So if the ball is moving in such a parabolic trajectory, then what is the influence on the very top of the ball? What is the influence? So you have to understand the influence over here. So what are we being influenced with? Where the influence is coming from? It's from gravity. So at the maximum point, you're going to have a horizontal component that's not influenced by gravity. And we do not know the horizontal component just yet, but we're going to derive that pretty soon. But we also have to take a note of the vertical component right here. This vertical component. And what do you think this vertical component is going to be? At the maximum point, when you throw a ball, let's say when you're doing linear motion in physics, when you throw a ball upwards and it kind of goes and falls or comes back down at the same point, let's say, what did you consider the maximum velocity is going to be? At the maximum point, the final velocity is going to be 0. So for a projectile motion, it's the same thing. If you notice, at the very maximum point, the horizontal component is going to be instantaneously 0, and then it's going to be immediately going to negative horizontal component. That means at the maximum point, you're going to have a vertical displacement, a vertical component of 0. So you're going to work with the vertical component if you want to find the maximum height. So we can derive a formula. So I'm going to go ahead and do it in blue just to indicate that everything we're doing is related to the vertical component of the projectile. So we can use the formula v square is equal to u square and 2as. This is a Suvet equation. So if you are not familiar with Suvet equations, then you do need to revise your mechanics syllabus. So for the v square, which is the final velocity, is going to be 0 squared, which is basically 0. Now for the initial vertical component, when the object is projected, it's basically, let's say the object is projected with a velocity of v meters per second. So its vertical component is going to be v sine alpha if it's projected at an angle alpha. So it's basically v sine alpha whole square plus 2. The acceleration, which is downwards, is basically g meters per second square, which is basically 9.81. So you can actually even plug in the value if you want to. But just to make it easy, I'm going to make it or just assume it to be g. Now, when the projectile, even though its vertical component reaches 0 in this case, so if the vertical component over here, even if it's 0, at the instant when it's its maximum point, it's still trying to move upwards, but it does have a vertical component of 0. But it's trying to move upwards before the vertical component is converted to the negative. That's when the acceleration acts downwards. But when it's 0 instantaneously, it's still going to move upwards, making acceleration negative, downwards. Now, the acceleration could have been considered positive if you took upwards moment, which is the velocity, like if you took minus v sine alpha, or if you took the, let's just say, the final velocity minus 0, or if you just took the other components negative at the top, then you could have considered acceleration positive. But you're not considering that. You're considering everything else positive, so the acceleration is going to be the opposite of that since it's moving along with gravity. So it's going to be, I'm just going to do it in blue, minus g, and then this s is basically the height, h, that we're trying to find out. So basically it's going to be 0 v square sine square alpha minus 2g h. So let's make 2g h to the other side. V square sine square alpha. So h is basically v square sine square alpha by 2g. So this is our first formula for a projectile. So this is the formula for maximum height. Formula for maximum height. So we have found out a general formula to find out the maximum height of a vertical projectile. Okay, now let's say you want to find the total time this projectile takes. This projectile takes to reach the final point. So this is going to be my total time. This time t seconds, my projectile is going to take to reach its maximum height. Okay, so how are we going to be finding that? So this very end point of motion right here. So this is the projectile, and this is going to be a final point where the projectile hits, right? It's moving at an angle alpha, and we want to find the total time required for this particular motion. So now we're going to make use of the a is equal to v minus ut. So we do not actually know the exact velocity the projectile actually hits the ground with. This v is unknown to us. So what you're going to do is you're going to make use of this top point once again. Now, since it's a parabola, what if we divide this parabola? We have half of the motion here, half of the motion here. This is where the projectile is its maximum. So we derive that the maximum, this downward v, or the vertical component, is going to be 0. So what you're going to do is we're still going to be using, this time we're going to be using this formula, which is a equal to v minus ut, where a is just basically negative g, v is going to be our 0 minus v sine alpha by t. So minus g is basically minus sine alpha by t. So this is going to be canceling out. So t is basically v sine alpha by g. Now this is going to be, I'm going to denote this as small t, but we need to find, oops, this is small t, but we need to find the total time. So the time we just found out was actually this much of the t, but we also need this t. Since it's a parabola is always symmetric at its maximum vertex. So this is obviously going to be symmetric at its maximum point. So if this was t, then I can also pretty much guaranteedly say that this part is also going to be t. That means the total time, which is basically t. Therefore, total time, which is capital T, is 2 times v sine alpha by g, which is 2v sine alpha by g. We're going to call it total time equation. So far we have derived two equations for the projectile. And the final equation that we actually need to derive for the projectile is going to be the range of the projectile. So this range can be derived in different ways. It can be used with the horizontal component. It can also be used with the vertical component. So let's go ahead and try to use the horizontal component for range itself. So since we can say that the horizontal component is obviously going to remain same the journey. Why is it going to remain the same? Because there is no force acting on it. So what's going to be our initial horizontal component, which is the red x this time? So this time we're going to work with the horizontal equations. So the initial horizontal displacement is going to be v cos alpha. So we're going to write S is equal to Vt for linear motion, where S is going to be considered range, V is going to be considered V cos alpha, so V cos alpha, times the total time, which is V sine alpha by G. So you're going to write 2V sine alpha cos alpha by G, which is also R. Now we are going to be using our admaths knowledge over here, where 2 sine alpha times cos alpha is the equivalent of writing sine 2 alpha. So you're just going to substitute it. Now you can keep the equation like this. It's pretty okay and obvious to do, but the general equation that is accepted by everyone is just basically v2 sine alpha by g. So that's the equation for range. So equation of range or total distance. So to sum up all the knowledge that we just gained, when a projectile is thrown like this at an angle of theta to the horizontal with initial velocity v, its maximum height is going to be denoted as v square sine square alpha by 2g. This is the first equation that we have derived. To find, so this is going to be the height, which is h meter. The range of the projectile is going to be defined as v sine 2 alpha by g, which we have just derived. And finally, the total time t second, time total, is going to be derived as the simple equation of 2 right here. So time is going to be 2v sine alpha by g. So in this equation, I hope that we have go ahead and got a general idea for the equation of a projectile.